Today I would like to show you how to debug the bootloader I built. We just loaded, and then in another panel we use GDB, set a target remote address with the right port, and then set architecture. After that we add the symbol file. Set the base address to 7C00, where the BIOS loads the boot sector. At this point, we can set a breakpoint at the start to catch the beginning of our code. However, after the code performs a far jump, the CS segment changes. At that point, GDB cannot match function names anymore, so we need to manually calculate addresses. To help with this, I wrote a GDB helper function called R2A, which converts CS and REIP pair into a linear address. As you can see here, we converted the address to the linear address. We can set the breakpoint now. And then we can do it again to get all the function location and set the breakpoint. Now let's run stage 1. You will see it prints the active partition information including head, cylinder, and driver number. Then it jumps to stage 2, which handles password verification and continues the boot process. Another useful technique is setting a watchpoint on memory. In our bootloader, stage 1 passes the parameters like head, cylinder, and driver number to stage 2 through a fixed memory address. By setting a watchpoint on that address, we can catch the exact moment when stage 1 reads those values. As you can see, we set some points here, and we set 3 watchpoints, and finally you see, okay, after here ES, we will see the ES is comparing with the original code. It should be the right address, and then we can use R2A function to calculate the exact address. But sometimes we don't have a fixed address. In that case, we can use a unconditional search. I wrote another helper called wait until condition. This function runs the CPU in a single-step mode and stops only when a certain condition is met. For example, when a register or memory value matches something we expect. This is especially useful when we are loading the stage 2 from disk into memory, which can take a lot of instructions and time. Think of it as running the CPU in a slow motion to catch the exact moment we need. We can also add filters like limit the search to a specific address range, or only checking every few instructions to speed up and narrow the search. To summary, we used R2A to calculate address after segment changes, wait until condition to locate dynamic events, and watchpoints to monitor when the memory values are written. Like then stage 1 passes parameters to stage 2. With those tools, we can fully trace and understand the boot process. Thank you for watching.